So you guys are right. Angle similarity is what we're going to look at here in terms of a title. So essential question. I'll read this real quickly. You guys follow along. It says, what can you conclude about two triangles when you know two pairs of corresponding angles are congruent? Now, we kind of talked about this right here, kids. Again, how many degrees in a triangle? 180. Okay. If you know two angles, can you find the third angle? Okay. And we've talked about similarity preserving angle measure or having same pairs of angles be congruent in terms of similar figures. Today, specifically triangles. But guys, we're going to talk about that right here. We're going to talk about using the angle similarity theorem to prove triangles similar. And we'll look at some real life problems involving this. And I don't think I need to go over this very much, Ken. Vocabulary is going to look very much the same as it has in the past few sections. Okay, so similar figures again, shapes that are what? Shape is the same. Size is what? Okay, angles stay the same. Sides are proportional, if you will. Okay, and we've talked about that already in previous sections. All right, guys, what kind of transformation changes the size of a figure? Remember what that was called? Start with a D. Dilation. Okay, a similarity transformation involves a dilation somewhere. Okay. Okay, so a similarity transformation, it's going to keep the shape the same. It's just going to do what? Make it bigger or smaller. Okay, similarity transformation is typically an enlargement or a reduction. Okay. Might include some other form of a transformation or rigid motion prior to that dilation or after that, but still, nonetheless, figures are going to be similar. Okay, guys, we're going to talk a lot about this today using the angle similarity theorem. Okay, all right. Here's what this theorem says: if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are what? Okay, up here, kids, and you don't really need to write this down, but it says angle A is congruent to what? Okay. Those two pairs of angles are congruent, right? It also says angle B is congruent to angle what? Okay. It says if you have two pairs of angles congruent, then the two triangles are similar. Okay. ABC is the same triangle as DEF. They're just a different size. Now let me just give you a reason why. Okay. Pretend that I say that this angle right down here is 30 degrees. And I say angle B is, I don't know, how about 100 degrees? Okay. Go over to the bigger triangle in red. What would angle D have to equal? What would angle E have to equal? Okay, so let's just jump down here to C and F. Okay, you guys told me, well, 180 degrees. How many degrees would C have to be? F would also have to be what then? Are all the angles the same? Or do we have three pairs of equal angles in that? So if that's true, then the figures definitely have to be same shape, right? Okay, so how many pairs of angles do you need to prove triangles are similar? And that's called the angle similarity theorem, okay? So let's just jump over to page 2. Okay. Guys, example 1 says use the angle similarity theorem. Determine whether the triangles are similar. If they are, write a similarity statement. Okay. Well, what two angles jump out at you right away in terms of being equal? Angle X and angle R are both how many degrees, kids? 21 degrees. Now, do the 61 and 99 match? No. But it might be a good idea for us to do what, kids? What angle don't you know in the first one? Angle Y. Could I find angle Y if I know two angles? Okay. So angle Y would come from, wouldn't that be 180 minus 99 minus 21, kids? You guys agree with that? So what would angle y equal? 60 degrees. Okay, so let's put that in here. Angle y is how many degrees? What angle don't we know in the bigger triangle? Wouldn't that be 180 minus 61 minus 21? How many degrees is that? 98. Okay, 82 and yep. S would be how many degrees here? Guys, do I have pairs of angles that match? 21's a match, right? Is there another pair of angles that match? So can I use angle-angle similarity here? Okay, so in this one right here, I can only say how many pairs of angles are equal. Let's say only one pair of angles are congruent. We need at least how many? Excuse me. Only one pair of angles are congruent, so I would say the two triangles are not similar. Okay, does that make sense to you guys? Okay. Okay, next one says show the angle QPR or triangle QPR. I'm going to highlight this. You don't need to do that, but QPR is the big one all the way around in the outside, isn't it, kids? What do you have at angle P down there for that big triangle? Okay, show that this angle is the same as triangle, what's it say, QTP? What angle do you have down there? 90 degrees. So we've got one pair of angles, 90 degrees in the same, the small triangle on the left and the whole big triangle. Okay. Guys, what one angle is in both triangles? This smaller one here and this bigger one right here. What one angle is in both of those? Not P, but, well, P is to an extent, but it's a different angle for both. Isn't angle Q up there part of both of them? Okay, so guys, could I say this? Since angle Q is in both, and each triangle that we're talking about has a how many degree angle? We can say then that triangle QPR must be what? What's that little squiggle symbol mean? Similar to triangle QTP. Because we showed how many angles are congruent, kids. How many pairs of angles congruent there? 2, you bet. All right. Ready for the last one, kids? It says a school flagpole casts a shadow that is 45 feet long, and at the same time, a boy who is 5 feet 8 inches tall casts a shadow that is 51 inches long. How tall is a flagpole to the nearest foot? Okay, let's go with the flagpole first. How tall? We don't know how tall the flagpole is, so I'll make the flagpole. kids, shadow would be on the ground, wouldn't it? And the flagpole is going to go up in the air. So we're going to make an assumption about the flagpole and the ground. Hopefully they're 90 degrees apart. Okay. Here's your person right here. Person's shorter than the flagpole, isn't he? Now I've got to be careful on this right here. Okay. Call this the flagpole up here. And this the person right here. Okay, do we know the height of the flagpole? I'm going to call the height of the flagpole X. Is that all right? Okay. How long is the shadow? I know this is 45 feet down here for a shadow then, isn't it? Okay, now we've got to be very careful on the boy, okay, because the boy is what? 5 feet 8 inches, but he says he casts a shadow that is what? Okay. So here's the deal. We're going to find the flagpole in feet over here, aren't we? Guys, on the left, am I comparing feet to feet? On the right, what do you have your shadow length measured in? What unit? So it'd probably be a good idea to have his whole height in what? Inches. 5 feet 8 inches. 5 feet 8 inches. 5 feet 8 inches is his height. How many inches are in a foot? 12. So I would take 5 times what? Which is? Plus how much more? How many inches tall is this person? Okay, so here's what we would say then, kids. How tall is a flagpole then? Well, we could say X is to, what's X correspond to over on the right? As 45 is to what? Okay. Guys with me on that? That's a lot of the stuff that we've done in terms of finding unknown lengths with similar figures prior to this, but this is how this kind of applies. We assume we're going to make the same triangle with shadows. So let me pull my calculator up. Guys, what time's what to start? And then divide by? Okay. So to the nearest foot, how tall is that flagpole? So X would equal 60. Flagpole is 60 feet tall. We should probably start another section today. Maddie's shaking her head no. Keegan smiled, which maybe makes me think he wants to do another section. Is that a no too? Reese, humor me and say you want to go on to another section. All right, you guys win. Hey, here's what I'm going to do, kids. First of all, any questions for me on any of this at this point? Okay, pretty simple. Again, kids, in a triangle, how many pairs of angles do you have to have equal to know that they're similar? 2, okay? It's kind of like saying if you know 2 angles, then you know all 3 angles. All right, let me stop this.